If all your component in your reactor are in a gas phases, how do you ensure that there is no increment of pressure? Or there will be not that high, and we believe that we just put pressure relief valve is sufficient enough as a safety precaution. It's up to you.
Oh, we can.
You can decide. It's your own as long as you can justify.
We can use that word.
Okay. Okay, so we move to another equipment. Can we move to another equipment? Oh no.
Pressure is a new control.
Yes, if you want to control a pressure, you will need another loop, another control loop, which means you need another type of sensor, which is pressure sensor. You will need another type of controller, which is, uh, I don't know. You want to use PI or PID controller, meaning to say another unit of controller to control your pressure.
Objective is formed.
Yes, another new objective and another table.
So another drawing.
Yes, another drawing. Okay.
So we have to find macam banyak type of CV lah, madam. Cari semampu mungkin.
It's actually it's not for you to find as much as CV as you can. No, it's actually for you to understand why you need that control system, why you need to control that variable. What happen if you don't maintain it? For example, this one, a temperature as your control variable. What happen if you don't maintain your temperature at 340 degrees C? No reaction occur? Or another reaction? Or what happened to your product? It's effect. I did explain why you need a control system. It's affect your product. It's affect your quality.
So if we put the pressure as the control, so that means our pressure maybe is not constant.
Not to say maybe. In reality, nothing is constant. It keep on changing by time. It just the range it change that big or that high. Still in that tolerable. You can tolerate with the variation or very high. If you don't control your temperature, this temperature will goes up and run away reaction and explosion. That is for safety issue. You need this control system.
So semua ni also need to control level flow rate.
If it is really required at that equipment, at your equipment, not necessarily the same. Your reactor might need temperature control, pressure control maybe, but another group maybe not. Maybe just control a level, maybe just control another thing. Don't put all these variable into all your equipment. No, you have to verify. You have to identify which one is really needed. It's really needed. Why you really? We really need it because of safety issue, because of the product quality, because of the economic, because of all that. First, determine your control variable correctly. In order to determine your control variable correctly, you have to understand how your equipment work. Increase temperature decrease. What will happen after decrease or decrease in temperature, pressure? Okay. So it's not that easy to determine this CV and VDB.
Madam, kita must state value
State the value.
of pressure tu loh. Macam dia naik bagaimana mana.
You can put that in your explanation if you want to put it in your explanation. After you build up this table, you wrote everything. Make sure you explain everything in this table into a paragraph. Then you can put an example. Let's say when your temperature increase, the controller will give a signal to a control valve to open further so that the flow rate will increase. With the increase of flow rate, more heat being transferred, then the temperature will reduce, so that you have a clear that you have that. Okay, you understand that when I mark, maybe another examiner Okay, this group can understand process control very well. Okay, not just CV is one, DV is one, but you don't know the relationship. Something like that. Okay, so you want to discuss another two equipment? I saw it here. Your vaporizer, your CV is temperature outlet, your MV, flow rate of steam, your DV, flow rate inlet.
Temperature of steam.
But it will be constant kot.
Constant, what constant?
Temperature.
Temperature of steam.
Temperature, inlet temperature of steam. We don't care about the outlet temperature of steam. After it absorb your heat, cooling down, reduce your temperature. That's another. That is not in your syllabus. In reality, there are another utilization of the heat. It called heat integration. That is beyond away from your syllabus. It's okay. Don't need to think about it. Okay. Don't need to think about it unless you really want to think about it. Want to do it. It's okay. Okay. So, your disturbance is inlet temperature. Okay. So your vaporizer, the design, just like heat exchanger ke?
Ya.
So which one should be in your tube? Which one should be in your shell? Okay. So all that you can put into your explanation. You can put that into explanation. Don't explain something yang not related then and also something that you don't understand. Group pagi tadi dia cakap PID is used as the PID oscillation dampen from PID. I even don't know what is the meaning of that sentence. Don't write something that you don't even understand. Okay, you copy somewhere PID is blah 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 and steady state error. Tell me what is it? Okay, if you wrote that, okay, that is the correction lah. You have to do later.
So you have to explain the meaning lah first. Baru explain what we are doing macam tu. Yang part kita tu.
Okay, you can explain what is PID, what is whatsoever, what is to. You can just copy somewhere or whatever. But how to relate that to your system? If I may ask you now, what type of controller you want to use? PI or PID? Saturated. You dari lab
Yeah.